Aloha. Hope everyone is doing well. Let's see. We are still going to be shooting for a Zoom meeting Wednesday. It'll be April 2nd. Great. At 12 o'clock. Yeah. So I'll get the Zoom link up to La Lima and get an announcement out and everything, and get that on everybody's radar. Great. Yeah, looking forward to checking in with everybody and see how it's going. I'm sure it's been, it's a transition for everybody. So appreciate your flexibility. Those of y'all that are reaching out, I appreciate it. Any comments or feedback, I'm more than happy to have. Again, I'm sorry about the quality on this not being great and it being switched and everything. Again, really, just if this could mainly be a audio file, right, to follow along with in the slides. So just put it on the back burner. Don't try to look at it unless you can look at it in a mirror. Great. So we're going to finish up soil organisms. Today, the last segment is on ecosystem engineers. Okay. And we'll also go back through a little bit of taking a step back and looking at our food webs. So, ecosystem engineers, definition: organisms that make major alteration to the physical environment, influence habitat for other organisms within the ecosystem. Okay, so we have things like us, right? We're making major changes in the soil ecosystem, right? Biotic crust in deserts. Crypto is a term for some of those that occur in arid climates where, excuse me, I don't want this to die, where nutrient concentrations, small organic matter is concentrated along a thin crust at the top layer of soil. And then our burrowing macropaunas, earthworms, ants, and termites, and our prairie dogs. Okay? Organisms that make major alterations to the physical environment. All right, earthworms, definitely an engineer. Okay, earthworms have a number of functions on soil and soil health. Okay, I would love to ask you 3 effects of earthworm presence on soil health. Okay, so what do? They stimulate microbial activity. How? They eat microbes, right? How could they be stimulating the activity? Drive nutrition from microbes, and also organic matter, right? Other decaying. There also could be shredders to an extent, right? And eating plant material in with some microorganisms, right? And then all that material is getting processed and broken apart and fragmented, and surface area is increasing in the gut of the earthworm. It's also getting imparted with enzymes, right, to break down that material that aren't present, right, outside in just the soil, in the rhizosphere, even in the pedosphere in general, right? There are only those enzymes that break down materials in a certain way are only located in the earthworm gut. So you'll only get, right, certainly processed organic materials in the soil with the presence of earthworms. Great. Greater microbial biomass of the feces and casts. That's where, than in the surrounding soil, okay? So if you were to take a sample of earthworm casts and then a sample of mineral soil, so it'd be a little bit obvious, right? But just to get things clear and start at square zero, okay? There will be a higher microbial mass in the casting than in the soil, okay? And that turns that area into a microbial hotspot, because what do microbes eat, right? It's decaying organic matter, dead bodies of other microbes, and excrement of other microbes, right? Excrement of other soil organisms. Earthworms mix and aggregate the soil, right? We have casts expelled after being put through the gut, and while it's going through the gut, right, we have those mixes, right, of organic matter, plant residue, right, lignified cellulosic material, mixing up and binding up with a bunch of mucigels and digestive enzymes, right, with dead microbes as well, okay? So we are essentially getting nice little soil aggregates, okay, after getting processed through the earthworm, right, and deposited as a cast, okay? And then those casts can be thought of as little almost micro aggregates, almost in themselves, organic matter micro aggregates. But then those little casts are gonna, like we talked about earlier in structure and soil physical properties, okay? Those casts are going to aid in holding together other mineral soil constituents, thus enhancing overall soil aggregation. Okay. And also importantly, similarly to, for example, dung beetles, okay? They bring organic matter deeper into the soil profile, which then protects that organic matter from decay and then rising back into the atmosphere as CO2, which we don't like since CO2 is a greenhouse gas, okay? So they really can bring organic matter down to an area where it's essentially protected. Increase water infiltration and improve water holding capacity. How, I would say, but there's no one in this class. How, Herman, do earthworms increase infiltration, water infiltration, and also improve water holding capacity? By increasing the porosity, mainly. And increasing, mainly, right, the macro porosity, okay? Where we're gonna have a lot more, or macropores, we remember, are really helpful for water infiltration, okay? And so we have preferential flow paths being created from the earthworm trails, and that minimizes surface water erosion because it enhances drainage and percolation and water infiltration quicker, so we don't have standing water, which results in lateral loss of soil, aka erosion, right? And in fragmenting organic matter and increasing soil porosity and aggregation, we improve our water holding capacity, providing more areas for water to form films and fill up micro and macro pores caused by aggregation. Also provide channels for roots to grow in, okay? If we're in an unhealthy soil suffering from some levels of compaction, for instance, right? It certainly won't be overnight, but the presence of earthworms are going to some extent, really, help root infiltration into soils that might have been dispersed, right, where aggregation has been lost, high clay soils, right, or compacted. Bury and shred plant residue, went over that it aids in protecting organic matter within the soil profile, and then also depositing nutriment, if we're talking about from a plant growth point of view, okay? We're providing nutrients, all those plant residues and the castings that are deposited lower down, right, are nutrient rich. And we've looked at, to some extent, right, that essentially all plant nutrients as we go further down the soil deplete in amount, right, in quantity. So here's a nice little video to look at that goes over some instances of earthworms being planet recyclers. So give that a look while you're stuck there in quarantine. I know you don't have an excuse not to. Okay, we'll make that one video and then finish it up with this food web.